Okay, so there's this equation called PV equals nRT, and if you guys got the chance, if those who did, you guys know what does P stand for, or if you just want to guess if you did not watch the video.
ATM and H.
So yes, this chapter is about gases.
Yeah.
And P stands, the unit is ATM, you're right. But what does P stand for? Like, what is it called? What is it? It's the abbreviation of what?
Pressure.
Pressure.
Pressure, yes. So it is pressure. And what is V?
Volume.
Volume. And then what is N, guys?
Moles.
N is moles. And then what is T?
Temperature.
The temperature.
Temperature, right? Okay, and then R is?
Rate.
R is a gas constant in this case, okay? It's a constant for which the symbol is R. So by constant, guys, what do we mean by a constant?
It doesn't change?
It doesn't change. So it has a fixed number. So somebody did the experiment and figured out this number for us. Okay, so R is a constant and the units, we'll do the units later. I'll ask you guys to tell me the units, okay? All right, so PV equals nRT. So guys, imagine this, that if you're thinking about a gas in a chamber, or let's say, how do you tell, guys, if you're, what is the amount of air in a car tire? Like, what do we find out?
The pressure.
We found
The
out
gadget, the pressure.
we found out the pressure, right? So when we talk about gases, we need to know, see, if you want to figure out the moles, you see N is moles, and moles basically tell us what is the amount of gas we have. That can be figured out if you know the pressure, if you know the volume of the container, and if you know the temperature. So pressure, volume, temperature, and moles, they all are connected to each other, and we use this equation for getting that connection. Okay, now what you will see in these type of questions is, so guys, if R is a constant, as we just know, R is a constant. So how many variables do we have in this equation? Variables is the things that can change.
4.
4, which is P, V, N, and T. So these 4 things can change. R is a constant. Okay, so never in the exam I'm going to be asking you R value because it's a constant. But the 4 variables that you see here, out of the 4 variables, 3 will be given to you and 1 will be missing. So will you be able to find that, guys?
Yep.
How would you do this? So let's say guys, we have this equation PV equals nRT. Can you guys isolate this V for me? So keep V on one side and don't want anything else here. So what should I write on the right hand side, guys?
Divide by P on both sides.
Divided by P.
So divide by P on both the sides, right? So when you divide this by P on both the sides.
Shower, I already did my homework.
Whose homework? Our homework? Homework? Okay. Right. Okay, so we're dividing P on both the sides. So, oh no, sorry, not that one. So we got rid of the P on the other side. So we got nRT over what, guys?
P.
Over P, right? So we made the equation, we modified our equation, and now we have V isolated, right? So that's one of the things that's actually very important for this chapter, is that you guys should be able to isolate the variables, okay? So let me give you one more equation, one more question. Guys, can you isolate N for me? Okay, let's do this together, okay? So N is the one we want to isolate. That's the one we're interested in. The one that you're interested in, if it's on the top, by that I mean if it's a numerator, which it is, keep it where it is, keep the other things where they are, and the thing which is on the N side that you're trying to isolate, what do I do with these two?
Divide it.
You divide it on both the sides. So basically you can divide it, or simply you know that you can, since this is a numerator here, if you want to move it to the other side, you have to make it a denominator. So this will become this. Right, guys? So again, you might have your own methods of doing this and everything is fine. It's just that you should be confident with your method. that how do you isolate this? That's a common mistake on the exam, that you know how to do everything, but in this isolation step, you mess this up for some reason. And this is the most common one, guys. PV equals nRT, where you have to find the N. And instead of doing PV over RT, for some reason, you say N is equal to RT over PV. And that's incorrect. Okay. So now that being said, guys, let's say if you were looking for N, and if I give you the value of pressure, volume, and temperature, will you be able to find N, guys? Yes, right? So you just plug in the numbers and you get the answer, because R we already know. R is always given,
Oh, yeah.
right? So R is 0.0821. We know that number. So that number we always know. If I give you PVT, then you can find N, right, guys?
Yes.
Okay, so that's what you do for these questions. Okay, now the important part is that the units, we need to worry about the units. We should know what units to use for this equation, guys. For P, which is pressure, guys, what is the unit that we use in this chapter? Again, when you watch the video, you will find out what is it, but those who did, do you guys remember what is the unit for pressure?
ATM
Either like mercury.
HG.
So yes, so there are two units. ATM is the one that we always use if there's R around.
Oh, okay.
Okay, so I'm going to say here ATM. The other unit is mmHg. You can use, you must use, so must with R. When you're given the R value, when you see a question PV equals nRT, guys, in this equation, if you're using this equation, do we have R in that equation?
Yes.
Yes. So then pressure must be ATM. I'm going to show you one equation, okay? In that equation, tell me if there is R in it. Let's say this is my equation, okay? P1V1 equals P2V2. Do you see R in this equation?
No.
No, there's no R. When you don't have R, you can use any unit for pressure, ATM or mmHg. Both are fine. Does that make sense, guys?
Yes.
Okay. Now, so we did the pressure. Now tell me, guys, volume. What is the unit for volume? Unit for volume, guys?
Centimeters cubed.
Not centimeter cube, but something else.
V.
Meter.
What's it?
V.
V is a symbol. See,
ML.
when you tell me symbol for pressure is P, symbol for volume is V, but what is the unit? Like ATM is a unit, mmHg is a unit for pressure. volume. So ml or L. So milliliters or liters, right? So it's liters that we need when we have R next to us. In our equation, if we have R, we must stick with liters. Okay? Here, if you don't have R, so no R, like here mmHg is okay, ATM is okay. For when you have no R, then even mLs is okay. Or centimeter cube is okay. I mean, let's say if you're using this equation, guys, you see there are two volumes here. They have to match their units, but they don't have to be liters. Because, why, guys? Because does this equation have R or no R?
No.
No R. So when this equation does not have R, it gives us the flexibility. But since this is volume 1 and this is volume 2, if both are milliliters, milliliters, very good. If both are centimeter cube, very good. But if one is milliliters and the other one is liters, is that okay?
No.
No, then you have to change either one of them, depending on what the question is saying.
So if there is an R, and they give us like you know, as are given in like a different, or like a
You
centimeters
must
cube,
change it to
or
liters.
okay.
Yes, yes. So when we are using R constant in the equation, we must stick with these units that I'm going to be putting here. Are you guys? Are we good?
Yeah.
Now, if there's no R on the bottom, you still want to switch it to liters, right?
You don't have to switch it to liters. They must match with each other.
Okay.
Okay. So if I'm using the equation where I have, let's say, P1V1 equals P2V2, and I give you two volumes. Let's say I give you volume 1 is 5 mLs, and volume 2 is, let's say, 0.01 liters. So this is milliliters, and this is liters. Now, if you are given this, you gotta match them, okay? Either change this ml to liters or change this liters to mLs.
Oh, it doesn't matter which one we pick.
Yeah, so which one you will pick will either depend on the question or it's not gonna matter.
Oh, okay.
So the question will say, okay, what is the volume in liters? Then you know I gotta change the ml to liters. If the question says, tell me the volume in mLs, then you know you gotta change liters to mLs.
Okay.
But they must match.
Okie dokie.
Must match. Now, guys, this is with R or without R?
Without R.
This down here, this is without R, okay? With R, you have no option. When you have R, you gotta have liters. Question
Liters.
says it or does not say it, you have to have liters for volume if you have R. Okay? All right, now guys, PV and then T. What does T stand for?
Temperature.
Temperature. Now guys, for temperature, what unit do you expect here? It's not Celsius.
Celsius.
Kelvin.
It's Kelvin.
Oh.
Okay. So we must use Kelvin, guys. And this is, guys, look here carefully, okay? This will be on the exam 100%. And if you don't hear this, you will get this wrong 100%, okay? So temperature unit has to be Kelvin when you have R or when you don't have R. Temperature unit has to be Kelvin for chapter 7, period. Okay, so if you have R or you don't have R, so let me give you one more equation, okay? V1 over T1 equals V2 over T2. Does this equation have R in it? No,
No.
R. Okay, now for volume, what is my unit supposed to be?
ATM. Or no?
Volume, first of all, ATM is not the unit for volume. ATM is the unit for pressure.
So it'd be milliliters, right?
So guys, again, listen here. When you don't have R, what is the unit for volume supposed to be? It can be any unit, milliliters, liters, centimeter cube, meters cube, we don't care. V1 and V2 units must match. That's what we care. Right, guys? Isn't that what we learned here?
Yes.
When you don't have, without R, when you don't have R, you have flexibility for using your units. Right? Okay, now for temperature, what did I say, guys? For temperature, what should be the unit when you don't have R? That's it.
Kelvin?
It has to be Kelvin, no other option. You guys get that?
Yep.
Yes.
Okay. And now, guys, why is this the case? Because, guys, how do you change Kelvin to Celsius? Now, this is not going to be on your exam, but this is conceptual. Like, why temperature has to be Kelvin only, whereas the other ones can be, like, volume can be ml, liter, centimeter cube, meters cube. Like, you don't have to stick with L. Why is that the case? What's that?
Is it because it's positive?
Because of what?
It's always positive.
It's always positive. That's a very good reason, yes. Temperature, when you put it in Kelvin, you will always get a positive number. So guys, let's see, what is the way to change, what is the formula for Kelvin? It's the temperature in Celsius plus, what number, guys?
Isn't it 250 something or 270 something? 275?
275. Yes.
Oh.
So this number, okay. So your temperature in Kelvin is temperature in Celsius plus this number 273.15. Okay, so let's say, guys, my temperature in Celsius is -10. -10 degrees Celsius. So guys, this becomes how much in Kelvin?
$10, you said?
So it's
two-
negative
negative
10. So it'll become how much?
263.15.
Right, positive 263.15. Did you guys see how when you change Celsius to Kelvin, even if when the Celsius is negative, it will change your temperature in Kelvin to positive number. Okay, that makes sense, guys, here? Or no?
Yes.
Yeah.
Yes, okay. Now, this is one reason we always want positive numbers, so that's why you gotta pick Kelvin. Now, when we are not using R, why do we still want to stick to Kelvin? Even if they were positive, even then we cannot stick with Kelvin, guys. Because the thing is that the scale for degrees Celsius and Kelvin is not same. Okay, like if you were gonna measure the change in Celsius, then that number is not gonna match with the change in Kelvin. So if you want to look at the scale, let's say this is thermometer, okay? And on the thermometer, if you change your temperature by this much, it will be a different value for Celsius versus if it was Kelvin. Okay, because the way the Celsius and Kelvin change is because of addition. You have to add when you have to change Kelvin and Celsius, okay? But when you have milliliters and liters, guys, how do you do that conversion? Can you tell me 200 mLs is how many liters? You guys
Is
can do
it
this in your head?
20,000?
Nope,
10,000?
nope.
I mean, 10,000?
So 200 ml has to be divided or multiplied by 1,000?
Well,
Multiply.
Multiply, are you sure?
I don't know what's the buy.
Liter is a bigger unit, so it has to be a smaller number, right? So you have to divide it. It becomes this. Okay, so guys, basically we actually divided this number by 1,000 to get the answer in liters. Okay, so guys, when you're doing division and multiplication, then it's okay to keep our units the same. That's when I was saying for volume 1, volume 2, if one is in mLs, the other one is in mLs, it's okay to keep them both mLs. But when it comes to temperature, you must keep Kelvin. So yes, if you don't get what I was talking about earlier, that's okay. Ignore that, okay? Focus that your temperature got to be Kelvin in all these questions, no matter you have R or no R. That's the point. You guys get that?
Yeah.
Okay, all right.
Oh,
So,
yeah.
And this is chapter 7, correct?
this is chapter 7, yes. And again, guys, this is, I'm just doing like a tiny review kind of thing. This is not your actual lecture. You got to watch your actual lecture from Canvas, okay? All right. Now, this is just one example, guys. You see, the question says how many moles of gas are contained in a typical human breath that takes in ½ liter of air, 1 atm of pressure, and 37 degrees Celsius. Guys, can you tell me what is given to us in this question?
50 liters of air.
So guys, let's start from the beginning. Let's see. Tell me exactly what you see here. So guys, in this question, first of all, tell me. Let's go word by word and see what is it asking for. So what does it say? How many moles of gas? So what are we looking for, guys? Tell me, what are we looking for?
Moles of gas.
Moles of gas. What is the symbol for moles?
MOL.
N.
N.
This is your question mark, right? Okay, and then what do we have? What else do we have? What are we given?
0.50 liters of air.
So 0.50 liters of air. Now it does not tell you what is this. What is this? When you see liter, what is this telling you? What is it?
The volume.
It's the volume. Okay. Now what else do we have?
We got the ATM.
ATM. So 1 ATM. What is 1 ATM? What is this?
Pressure.
This is pressure. Okay. What else do we have?
37 Celsius.
37 degrees Celsius. So what is this?
That's the
Unofficial.
That's
Temperature.
what? That's temperature.
temperature.
So guys, you see we are given VPT, and guys, we always have R. R is 0.0821. That's always given to you, right?
Yes.
So now tell me, how do I find N? What equation do we use?
First,
The
all
ideal
you need
gas.
to do is change into Kelvin.
Yes, so ideal gas equation, which is PV equals nRT. What are we looking for?
N.
And what is N equal to?
EV over RT.
PV over RT. Now, guys, can I just put all these numbers in here, or do I have to change something? Okay, look here, guys. Look here. Tell me this. Does the volume liter looks good? Is it the unit that it's supposed to be? What is the unit, guys, that we need for volume? I can go down. What is the
ml.
unit? No. What? Look here. What is the unit that we need for volume? This is volume. V.
Liter.
Liters.
We need liters. Do we have liters?
Yeah.
Yes.
So
Yes.
do we have to change this?
No.
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 No. Oh, baby.
For P, which is pressure, what is the unit supposed to be? Where'd it go?
TM.
Yeah,
ATM.
pressure has to be ATM. What is it given here in?
ATM.
ATM, do you have to change that?
No.
No. And temperatures in Celsius, what is the temperature supposed to be?
Kelvin.
Kelvin, so do you have to change that?
Yes.
Yes.
Yes. So this Celsius, I got to change to Kelvin. How do you change 37 degrees Celsius to Kelvin? So temperature in Kelvin equals, what is the formula, guys?
Celsius plus
Celsius plus 273.15.
5.
So what is the temperature in Celsius? 37
7.
plus 273.15. That's how much, guys?
10, 15.
110.15 Kelvin, right? Okay. Now, this is what, guys? This is temperature, right? Now, for finding N, can you find N, guys? What do I put here? What's the first number I put here?
1 ATM.
1 ATM. What is V?
0.50.
50.
0.50 liters. What is R?
0.0821.
Yes. So guys, for this, let me tell you the unit, okay? The unit is ATM liters over mole Kelvin. You don't have to memorize that. You should just have this handy all the time as you're going to take your exam. Make like a cheat sheet where you put all the formulas and the units and the unit conversion factors and the constants, okay? All right, so I'm not going to put the unit here. I don't have that much space here, okay? So let's see, 0.0821, but these units here. And then what about temperature?
37 Celsius.
Can I put 37 Celsius here?
No, it's 310.1.
Oh,
310.15 Kelvin, right? Right, guys?
what? How do you get that? What did I miss?
Here. Do you remember this?
Oh, yeah. Okay, got it.
We converted our temperature from Celsius to Kelvin, right? That's the number you got to put here for temperature,
Mm-hmm.
right? Okay, so now guys, you just do all the math and then tell me what do you get for N. So what's 0.50 divided by 0.0821 and then divided by 310.15. Okay, let's do this, guys. I want you guys to tell me the number on the top, which I can tell is 0.50. Tell me what is the number in the bottom. Multiply the numbers in the bottom. Tell me what do you get.
25.463.
28, you said?
25.
20.
25.463.
463, okay. All right, now when you divide these numbers, what do we get?
Divided by 25.
0.0196.
Anyone else also got that number?
Yes.
I got that too.
Okay, great. So guys, that's your answer. So you guys get the idea of how the math questions in this chapter is gonna look like?
Yeah.
Yeah.
So basically, all the math questions for this chapter are using some kind of equation. What equations? Again, watch that video. There's more than one. There's of course more than one equation in there. Like PV equals RT is what we just saw today. But I was showing you P1 V1 equals P2 V2, or V1 over T1 equals V2 over T2. So these equations also you're gonna see questions on that too. Okay. So again, watch that video, guys, now, and then you guys will tell me if you have questions. Okay. So, well, first of all, any questions right now, guys, about what we just went over?
Question.
ATM, what is that? Oh, go for it.
I can't hear you. Is that Jesus? Is that you? Your
She
maybe
can
voice
go
is
first.
getting-
It's okay.
No, it's okay. You can go. No, it's just a tiny question.
I just want to know what the ATM stand for.
What is ATM? ATM stands for atmosphere. Okay.
Okay.
An ATM, one ATM is 760 mmHg. Again, you're gonna watch that video and then see how you do that conversion, because in this question that we just did, the pressure was 1 ATM, but it may be given in mmHg, which I will be for sure on the exam. You will have to change it to ATM. Okay.
Okay.
Atlas, if you had a question earlier, or
Yeah, like, so when I get my answer, is there like a specific number of sig figs that I should put, or?
now for these questions, I don't, again, when the questions were about sig figs, in that chapter math review, I care about sig figs. Otherwise, I don't care too much about significant figures.
Oh, okay.
Yeah. I mean, your options are not going to vary based off sig figs. They're going to be drastically different numbers depending on whether you did n equals PV over RT, or if you did n over RT over PV. That will make a difference in the answer. And those are the options you can see on the exam. Or maybe you can see where the pressure is in mmHg. You were supposed to change it into ATM, but you forgot to, and you're going to see that option on the that option in multiple choice. So that's how the options are going to vary, not based off sig figs.
Oh, okay.
All right. Any more questions, guys?